And this will be our second screencast, so make sure you are able to have some earbuds so you can listen up and you're not distracting people around you. We're still going to have a chance to really briefly go over the graphing basics. So how to make a graph is a quick summary of what we did before, or at least went over in class, and as a part of the other screencast. Make sure you understand that the independent variable is your x-axis in our unit of motion. Most of the time, if not all of the time, time will be the x-axis measurement, and seconds will be the units. And dependent variable is going to be distance, or could also be position. So we'll be looking at a couple different graphs: distance time graphs or position time graphs. Make sure you make a scale. This was an example. A box can represent 1 unit, 20 units, or 40 units. So make sure you've defined what that is. Make sure you plot the points on your x and y coordinates, and then you'll connect the dots. And we will start looking at what the slopes, we'll start using the slope that we did in class today, where we identified that the slope is the speed of an object. So the rate of motion of an object graphed on a position time graph or a distance time graph is going to be the speed of that object. Moving on. So here, when we're reading a graph, I think it's important to read the title just to kind of get an idea what the graph is going to show you. Right? If I identify the units of measurement here, we've got kilometers per hour. So on this position time graph, my units of measurement are kilometers per hour. So on a distance time graph or position time graph, once again, we've denoted as distance and position as being somewhat synonymous for now. Be sure to interpret the numbers as to what the motion is taking place on the graph. So here's what you're going to do. Your job for your homework is to determine what is the speed for each of the three motions. So we're going to call this motion right here, we're going to call this part A. We'll call this part B. We'll call this part C. So you're going to come to class tomorrow and you're going to try to interpret what this graph is telling us for segments. What's the speed of segment A, segment B, and segment C? And then, very importantly, you're going to determine the average speed for the entire object's motion. So the entire is going to be the total distance traveled divided by the total time in which it took to travel there. So that'll give you a minute or two. That should challenge you a little bit. And last but not least, a couple of general reminders. The steeper the slope, the greater the speed. The slope of a distance time graph or a position time graph is the speed of the object. If there is no slope, there is no speed. So it is traveling 0 meters per second or 0 kilometers per hour or 0 whatever your distance or displacement or position is divided by the time. Therefore, the object is stopped, which is what physicists refer to as at rest. We'll get into distance and displacement within our next class. So there you have it.